Hi everyone. Can someone quickly tell me whether I am audible or not? Am I audible?
Yes.
Yeah, fine. Thank you. So, all right. So, without any further delay, let's start. So, I'll share my screen. All right. Yeah. So, before anything, as always, quick introduction. So, this course is. So before that, pardon me for my voice today. I am slightly sick, so my voice can be little. Uh, I mean, you might have some problems hearing sometimes. So if you have any problem, if you are not able to hear me properly, please say so. I'll repeat myself. All right. So this course is basic electrical circuits. It's an NPTEL course. All right, and the instructor for this course is Dr. Gajendranath Chaudhary. He is a faculty member in IIT Hyderabad. So, myself, I am Mayank Anupam. So, I hold these tutorial sessions on Saturday. I am a PMRF scholar. I guess most of you have heard what is a PMRF scheme. So, currently, I am pursuing a PhD in electrical engineering at IIT Kanpur. All right. So, that concludes the introductions. So this week we will be covering week four's content today. Okay. So in week four, I'm sure all of you have gone through the week four's content, the lecture things, the lectures, right? So in week four, what all did we learn in week four? So we learned about nodal analysis, right? So we learned about nodal analysis. So do you have any problem? Do you have any problem following the lectures? I mean, do you have any doubt in the lectures? If no, I will start with the problems. Otherwise, I will spend some time on the I mean, the lecture contents.
So this definitions around a branch node. Could you clarify it?
I couldn't understand what did you say? Could you please
Definition
elaborate?
for node and branch.
Oh, definition for node and branch.
Definition for node and branch.
Oh, node is not okay. Okay. So what's a node and what's a branch? See, if you have any element, okay, any electrical element, okay. Hello.
Yes, sir.
Yeah. If you have any electrical element, fine. Then basically it might have different two or more terminals, right, in
Yes.
associated with itself, right? Any electrical
Yes.
element will have at least two or more what no terminals associated with it, right? Correct.
Yes. Yes. Yes,
Now
sir.
uh, okay, Now let's so this is okay, let's call it unelectrical
element.
element. Yeah. Okay. Oh, let me do this. Yeah. Now it will be more clear, right?
Yes.
Yeah. Cool. So this is an electrical element. Now, node is nothing but the junction of uh, uh, any two or more electrical elements. Okay. Let's
Okay.
say you have one electrical element like this. Okay.
Okay.
Other
Hmm.
electrical element which is like this. Other electrical element which is like this. If two
Okay.
or more electrical elements, okay, so in this
Hmm.
case we have three electrical elements, isn't it?
Yes.
Yeah, so if two or more electrical elements they meet at a point,
Okay.
they share one common terminal. Okay, if
Okay.
two or more
Hmm.
electrical elements, if they share one common terminal, so
Okay.
that is a
Okay.
node, fine.
Okay.
Two or more,
Yes. Yes.
okay,
Yeah.
fine. And what is a branch? Branch is nothing but simply two nodes which are separated by
Hmm.
it's a collection of two nodes, okay,
Okay.
which is separated by an element, electrical element, nothing else.
Okay. 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 Okay.
That's all.
Okay, sir.
Yeah. So yeah. So anything else related to week four's content? Sorry. In nodal analysis, did anyone of you have any problem following the lectures? Okay, maybe I will start point wise. So definition of nodal analysis. Anyone has any problem with that?
No.
Okay. Then I mean, how to set up the nodal equations? Anyone has any problem with that? Okay, fine. So next is what? Yeah, set formulation of matrix. No problem here, right? Okay. Next will be what? Uh, nodal analysis. So nodal analysis with independent sources, right? No problem here. Okay. Next would be what? Again the same thing, but with VCCS, CCVS, CCCS, and what else? What am I? Okay, VCCS, uh, CCCS, VCVS, and CCVS. Correct. So no problem here. All right. So if no one has any problem with these things, so oh, so okay, I remembered something. Last week, I while explaining something, I made a small mistake somewhere. Let me go ahead and correct it today. Where was that? Yeah, this question. So those of you who attended the last week Saturday session, so this question was minimum number of mesh equations required to analyze the circuit given below. Right? The circuit is
Okay.
this one. This is the circuit. Now, what is the minimum number of mesh equations required to analyze the circuit given below? So I said that. So there is one. I mean, there is one way to find the one way to find this solve this question is you have to use that thing, right? That information that if you have n nodes in the circuit and b branches, then the total number of loops, independent loops which you will be forming will be b minus n plus 1, right? I mean, this is what this was already this is already known to you, correct? B minus n plus 1 is the number of independent
Yes,
loops
yes,
which will be
yes.
forming in the in the network, right? So the number of independent loops that you will be forming is the same as the number of the minimum number of mesh equations that you will be requiring to analyze the circuit, right? So in this case, how many branches did we have? We had we had how many branches? 9 branches, right? And we had 6 nodes. So by easy calculation, so it turned out to be b minus n plus 1 turned out to be 4, right? So it required 4 mesh equations, 4 meshes to analyze the circuit, right? So this is the way to solve this question. So what I also said was that in this circuit, since we have only 4 nodes, okay, I mean 4 variables, independent variables. By variables I mean independent variables. You see, in this question, you see, I said that if we try to see how many independent variables we had this v1, we had v2, we had v3, we had v4. Okay, so all these 4 are the independent variables. This node here, the one that I'm showing right now, this node here is actually already known to you, right? Because if we know vs, then we know what is the voltage at this node, right? So ultimately we have only 4 variables here, 4 unknowns, v1, v2, v3 and v4. So I said that since you have only 4 variables, 4 unknowns, you require at most 4 equations to solve them, right? That is what I said. I said that in this question, the question was asked how many mesh equations you need, but I took another approach. I said that how many variables I have, how many independent variables I need to solve for in this circuit, and that number of variables will give me the number of the minimum number of equations that I need, right? So here, since 4 variables are there, hence I needed 4 equations, right? That is what my reasoning was, but that is incorrect. Okay, when you are asked to find the minimum number of mesh equations required to analyze the circuit, you have to use that approach only. I mean, this is the approach. You have to find how many nodes are there. You have to use this approach here. How many nodes are there, how many branches are there, and then you have to use this formula here, b minus n plus 1. Okay, I hope that clears everything. All right, so yeah, so people who have some background noise, please could you please mute yourself. uh, Thank you. Okay, so let's start with this week's content. So let's first solve this question. This is okay. So this week I will simply be solving basically I will be showing some circuits, simple networks, and I'll be writing the nodal equations for that. Okay, and I'll expect all of you to help me write those nodal equations. Fine. So tell me how do I proceed to write the nodal equations in this circuit? So some of you please volunteer. What should I do first? So this is this part, right? Setting up nodal equations. Tell me what should I do here? The first thing that I should do. All right. So this is so first I have to assign nodes, right? So let's call this v1. This let's call this v2. Let's call this v3. All right. Okay, so this is also a node, but we'll simply be taking it to be a reference node. Okay, and we'll be grounding it. We'll call it node 0 or 0 volt. Okay, fine. So now tell me, what should I do next? Do I need to write nodal equation for this node or node
Oh,
V1?
it is V1 is 60 volt.
Yes, exactly. Yes. So it is directly shorted with a voltage source, isn't it? So that is why V1 is simply 60 volts. No need to write any nodal equation for this node. Okay, fine. You can always write a nodal equation for this node, but you will eventually be arriving the same result. So anyway, do not need to write nodal equation for this one. Fine. So next we move on to node V2. So tell me, what is your nodal equation for node V2? And what by nodal equation, what do I mean? I simply have to write KCL, right? Yeah. Tell me, what will be the KCL for this?
V2 minus V1 divided by 5
V2
ohms.
minus V1 divided by 5 ohms.
Ohms.
Okay. What else?
V2 minus V3 divided by 3
So, okay,
ohms.
1 second. So you are assuming this, you are taking current going out of this node to be positive, right?
Yes, yes, yes.
Yes, okay. V2 minus V1 divided by 5 plus V2 minus V3 divided by 3, right? Correct? What else? What will be this current? What will be this current? Okay, so this is again a case of voltage. What is this? It's the voltage control current source, isn't it? This is a voltage control current source, right? So this is the voltage control current source, VCCS. Fine. So here, while writing KCL equation, we do not need to do anything, but simply, so this current direction is what? Opposite to the direction which we have assumed to be positive, right? You see, this current is in this direction, whereas we have taken this to be our positive current direction, right? So we'll have to take negative of whatever current we are getting here. So here we'll write minus of 0.04 times Vx, right? And what is Vx? Vx is what? Vx is V3, right? V3 minus this node. This is 0 volts, right? So it is simply V3. Let me write 0. Okay. So this is our equation number 1. So let me, or no, let me write it in a slightly formal way. So this is V2. Let's collect terms of same. Basically, let's collect all V1, V2, V3 terms together. Okay. So V1 has what? Minus 1 by 5. Sorry, this is only minus 1 by 5 plus V2 has 1 over 5 plus 1 over 3. Yeah, that's all right. Plus V3 has what? What is V3? What will be the V3's coefficient? Minus
minus
1 over
1 by
3. Yeah, correct. Minus 0.04 is
4.
equal to 0, right? So here I have written V1, but let's replace V1 with 60 volts. So as we have already seen here, V1 is 60 volts. So let's go ahead and do that. So it is 60 into minus 5 is 1 by 5 is how much? Minus 12,
Minus
right?
5.
Yeah. Plus V2 into 1 by 5 plus 1 over 3 plus V3 into minus 1 by 3 minus 0.04 is equal to 0. Or Let's do this. Correct. So this is our equation number 1. Fine. So we have already written KCL at V2. Now let's go ahead and write KCL for V3. So what will it be? Yeah, what will be KCL for V3?
V3 minus V2 by 3.
V3 minus V2 by 3
3
plus
plus V3 divided by 5.
by 5 equal to
That's
0.
it's,
Right?
0.
yes.
Yeah. So this will again become what? So V2 into minus 1 over 3 plus V3 into 1 over 3 plus 1 over 5 equal to 0. This is the one, right? So we have gotten two equations, correct? We have gotten two equations now. We have only two unknowns, V2 and V3, and we have two equations. So we can solve it, right?
Yes.
So now let's quickly make a matrix out of it, right? Let's try to represent it in terms of matrix. So tell me, so how many rows and how many columns will the matrix have?
2, 2.
Yeah, right. It will have two rows and two columns, right? So what will this be? This will be G matrix, right?
Mm.
Generally it is a G matrix, so in this case it will not be. So let's forget that now. Okay. So in this case we have a nodal analysis matrix, right? Right? And
Yeah.
this is a matrix of unknowns, right?
Yes.
Sorry, vector of unknowns, correct? And this is what? Vector of known or independent, right? Independent sources, correct? Right? So tell me what will be the uh, so let's take, so we are anyway taking node 2 and 3, right? So let's correct our nomenclature here. So let it be 2, this will be 3, 2, and this is 3. Okay. So tell me what will be the entry here for node 2? Okay, by the way, this is V2 and this is V3. Okay. Tell me what will be the entry, first entry here? 2 comma 2 entry, and this entry here.
8 by 15.
8 by 15. Anything else? Yeah, you're fine. I was just trying to confuse you. Yeah, 8 by 15. And then what will be this entry? So this is complicated, right? We may as well take our calculator and just solve it. This is fine, right? This is fine, right?
Yes, sir.
Yeah.
Yes.
And what will this be? This will be 12, correct? Fine. What will be this entry? Minus 1 over 3. And this will again be 8 by 15. Alright? And this will be 0. Correct?
Yes.
Yes. So this is our matrix right here. Okay. This is our
Mm-hmm.
matrix right here. So how did we reach this matrix? We wrote first the KCL equations, and then we converted those KCL equations into a, a matrix equations, right? Correct. So now from the knowledge that you have, because you have already watched the lectures, could you have arrived at the same matrix just by just like that? I mean, let me. So let's take this. Let's copy this. Copy and then paste it here. Fine. Yeah. So let's call it V2, V3. Now tell me, could you formulate this matrix just like that, just by looking at it? Could you do it? Could you formulate the equation in matrix form just by looking at it? Okay, let's try it. Times. All right. So yeah, tell me, what should I do now?
Mm-hmm.
Or let's call this V1. Let's call this V2, because this creates unnecessary confusion. V1, this is V2, this is 1, this is 2, this is 1, this is 2. All right. Tell me, what should be the entry of the first at the first node here?
Calculate the current at the node, which is associated with V.
So what should it be?
Uh,
So for writing the node, for forming the for writing this term here, for finding how much will this be, what all things we need? I mean, we know that it will be actually the sum of conductances at this node, right? 1 over 5 plus 1 over 3, correct? That will be there, right? Am I right?
yes, sir. Yes, sir. Yes, sir.
Yeah. So first let's do that. 1 by 5 plus 1 over 3, correct? That will be there at node V1. Now we also have another current which is for the first which is coming at the first terminal itself, which is 0.04 times Vx, right? So this is a voltage control current source. So how do we represent it? What is Vx? Vx is basically V2, right? So this is the same as 0.04 times V2, correct? So the current at node V1 entering at node V1, right, is equal to 0.04 times V2. So where will that entry be? It will be here, right? Right?
Yes,
Am
sir.
I correct? Yes. And all right, fine. And what about this? What about this node here? This one comma, sorry, 2 comma 1 entry. So, or before that, let me write this entry here. What will this be? 1 by 5 plus 1 by 3, right?
1 by 5 plus 1 by 3.
Correct. And what will this entry be here? Will we have any entry here? Yes, we will have,
Common
right?
conductance between 1 and 2.
We'll have 1 over 3, right? Minus 1 by 3. Correct? Right? But since you see here, we have run into a problem, correct? So what is the problem here? Tell me. We have not used this 60 volt thing here, right? Nowhere in this matrix formulation we have not used it at all, correct? You understand what I am telling?
Yes, sir.
Yeah. So basically, when you are trying to formulate the matrix just by looking at it, just from the without writing KCL equations, this approach of simply assigning this node to 60 volts, it will not work. Okay. Like if you are a computer, you will not start solving. You will not start writing the KCL equations first, right? You will simply start looking at the nodes and filling the entries at the matrix. So what I'm trying to say is, you see this, you know how circuits are solved in the computer, in the simulator. You see
No.
circuits in the simulator, they are all stored in terms of graph. Okay, I mean graph. By graph I mean you have a bunch of nodes. Okay, a whole bunch of nodes, and you have the elements connected between those things. You have branches for them. Okay, only have, and you have nodes, all the nodes, and what the computer starts writing is, computer starts to formulate a matrix of those nodes. Okay, something similar to this. So in this case we have only three nodes, right? So this is also a node actually. Let's call this vref. Okay, so this is also a node. So computer starts by writing simply all the node matrix for all the nodes. Okay, so here we have three nodes, so it will start to form a 3 cross 3 matrix. Okay, and from there it will solve all the find all the voltages and currents and everything. Okay, so this approach, simply by looking at it, you cannot do it. Okay, I mean you'll have to assume, you'll have to define a node v1 also here. Okay, you understand what I'm saying?
Okay, sir. Understood.
Yes, so this will not work if you're simply trying to look at it and then write it. You will have to write KCL equations for this. You have to write KCL equation and then you'll have to do it. Okay, so if you want to do it, nevertheless, by looking at it simply, what will you do? Okay, so let's do this again. Same thing, copy and paste it. Now let's call this node v1, this is v2, this is v3, and let's call it reference 0. So we'll not worry about it. All right, so now we have a 3 cross 3 matrix. Okay, fine. So we have v1, we have v2, and then we have v3. All right, tell me, so what will be the nodal equation? So what should I do here for node 1? What will the current what is the current flowing through node v1? How will I write nodal equation for node v1? So that might be confusing. Start with v2. So tell again, what will be v2's equation? What will be the equation for v2? I mean, this is 1, 2, 3. This is 1, 2, 3. Tell me this entry, 2 comma 2 entry. This will be again 1 over 5 plus 1 over 3. Correct? And this is 0.04 times Vx, which will be minus, in which direction? Minus of this. So this, I think I made a mistake somewhere here. Oh, I made a mistake here. This is minus 0.04. Alright, so this will be minus 0.04, right? And this will be 0 here. Fine. What about this? This entry here, 2 comma 1 entry. What does this represent? 2 comma 1 entry. This, what does this represent?
Common resistance between 1 and 2.
Yeah, it is basically the combination of 1 and 4, right? 1 and 2. It will be minus 1 over 5. Correct?
Yes, sir.
Alright. What about the third one? The third three entries in this. So what is 3 comma 3 entry? That is simple to write 1 over 3 plus 1 over 5. Correct?
Hmm.
And what about the 3 comma 2 entry? This one minus 1 over 3, right?
Minus 1 upon 3.
Yes. And what about 1 comma 3 or 3 comma 1? Sorry, there will be 0, right? Nothing is connected between 3 and
0.
1.
No, no common.
Yes. So this will be again 0. Correct? All right. Now let's write for this one. Correct? So tell me, what
Hmm.
should I do here? So how do you handle voltage sources? Tell me, how do you handle voltage sources? How do you handle independent voltage sources? Tell me. So this is an independent voltage source, right? How will you handle it in a while for writing KCL equations for forming matrices? You form super node, right? Correct.
Yes,
The
sir.
terminals between which this voltage source, independent voltage source is connected, you form a super node, right? Between those terminals, I mean, you take both the nodes and you simply collapse them, right? To make to form a super node. So tell me, what will be the super node equation in that case? So you call this a super node, right? So between these super node, so this super node will be formed between which two nodes? This will be V1, right, and node 0, which is reference.
Hmm.
So you have to now start writing the equations which are part of both reference and this the and V1, right? Correct.
Hmm.
So reference you do not worry about, right? Reference is again nothing but you do not worry about reference. So you simply write about the KCL for V1, right? So tell me, what will be the first entry? You don't worry about this current at all, right? You don't worry about this current. So you only worry about this current. So what will be this? It will be minus 1 over 5. Sorry, 1 over 5 at
1
node
over 5.
at V1, right? And what else?
Minus 1 over 5.
At this node, correct?
0. Hmm.
0, and this will be
60.
60. How did you get 60? How did you get 60? All right. So this is not right, right? This is definitely not right. Correct? So don't get confused, okay? So this is not right. Here, if you start to do those things, I mean, you have already taken care of the relationship here, okay? You already taken care of that relationship here, so you do not need to do that twice. You will not get anything new out of it. You will not be able to form, because you see V1 minus. So when you are writing that equation, V1 minus V2, you are writing this equation, right? V1 minus, when you are writing this 1 over 5 minus 1 over 5 and 0. So what are you writing? V1 into 1 over 5 minus V2 into 1 over 5, which is basically V1 minus V2 over 5, which is equal to what? That current is equal to what? This current leaving this node is equal to what? So understand the problem here. So don't do that. So what should I do? Rather, I have already taken care of all the relationships here. So I simply have to do this, which is basically I have to simply write the relationship pertaining to the definition of the voltage source, which is what? The voltage is V1 minus 0, or V1 is equal to 60 volts, right? So I simply have to do this 1 0 0. This is 60. That's all. Nothing else. Okay. Did you understand what I did?
Okay. Equation converted into matrix form. Okay.
What?
Understood, sir. Understood.
Yeah. So basically, what I'm saying is that you already took care of the relationship here between the current of this. You already took care here, right? Took care of that here. You do not know about the current flowing through this, so you cannot use that. You cannot write an sorry. You cannot write equation of the same sort of this. You cannot write that here. Okay, you have to because you have already taken care of it. You simply need to define the voltage source here. That's all, nothing else. Okay, so if you do this, you will get the, I mean, when you solve this, you'll get the same thing as when you start solving it. You'll get the same result as by solving this equation. Okay, fine. So I mean, you'll all have to practice matrix formulation. That's important. Anyway, so let's now solve another one. Yeah, tell me now, what will be the, I mean, in this question we have been told to find the relationship V by I. So this is voltage V between this and this. Okay, between this and this we have voltage which is V, and the current is flowing out of this node. So assume that there is a voltage source connected here, which is of voltage V, and then you want to find out what is the current I here. So what will you do? Okay, so let's start by writing the KCL equations. Okay, so tell me how many nodes are there in this question? How many nodes do you see? So is this a node, right? This is a node. Let's call it node 1. So this and this are the same nodes, so nothing else. So here will this, let's call this node number 2, right? So I guess that's it, right? We have only two nodes here. This is the same, this is the same, this is the same node 2 only, right? Correct. Now tell me, what will be the KCL equation at node 1? Okay, so let's call this as node 1 voltage as V1, and node 2 voltage as V2. Okay, tell me, what will be the KCL equation at node 1?
V1 by 9K
V1 by 9K plus
plus V1
V1
minus V2 by 1K.
by 1K, nothing else, right? Should be equal to what? 0, right?
Yes, sir.
Again, let's collect terms of the same order. 1 by 9 k plus 1 over 1 k minus v2 by same to 1 by 1 k equal to 0. So this is 1. Right. Now KCL at node 2. What will that be?
V2 minus V1
V2 minus V1
V1
by
by
1k
1K
plus V2 by 100 plus, or let's call it 0.1k, since everything is in k, so that's all. That's what. Okay, and what else? Minus 0.99 times IB, right? It's a case of
incoming
current
current.
control, current source, right? So it's
Yes,
what?
yes, yes.
It's a current control current source, isn't it? So CCCS. So what is IB? IB is an unknown, right? IB is an unknown, right? But we know
Yes, sir.
IB, right? We know IB in terms of our unknown, the unknowns that we want, right? It is actually minus of V1 by 9k, right? What is IB? Minus V1 by 9k, isn't it? So let's do that. Let's replace it here. So this is IB is equal to 0, correct? Oh, by the way, it is not done. So we have this one, right? Now we also have this current I, right? This current I. So what will it be? Minus I equal to 0, right? You see, we have four sources. We have four currents at node V2, right? We have this current, we have this current, we have this current, and we have this current. So we have four currents. So that is why I have written four terms here. Fine. Okay. Now tell me what should I do now? Replace IB with this relationship, right? So IB is equal to minus V1 by 9k. So I simply replace it here. So I have V2 minus V1 by 1k plus V2 over 0.1k plus or minus rather plus minus 0.99 into IB is what? Minus V1 by 9k, correct? Minus I
Yes.
equal to 0, right? So what will it be?
Mm.
V2 minus V1 by 1k, and okay, let's collect all the terms that are of same thing, that are of same coefficient. So V1 multiplied by minus 1 over 1k, what else? Plus this one, right?
Mm.
0.99 divided by 9k, that's all, right? And plus V2 into 1 over 0.1k is equal to I, right? This is our second equation, correct?
Yes.
What do we need to find out? V over I, right? V over
Hmm.
I. And what is V? V is the voltage at this node, at node V2, right? At node 2. So, so in that case, what is V? V is simply equal to V2, right? V is simply equal to V2, right?
Yes.
It's at the same node, correct. So we have got two equations. One is here, one is here, and we want to find out. So V2 can be replaced by V here, correct? So that, yeah. So we have got two equations. We have got two unknowns, okay, but I mean, we do not need to find out the unknowns, right? We need to only find the relation between V over I, V and I, right? So that can be done here. So from this equation, we simply replace find V1 in terms of V2,
Sir,
and we replace that. Yeah,
V2 one term is missing, I think. V2 by 1k is missing.
where
Second term, V2, second equation.
second equation did I miss V2? Oh, yeah, right. Oh, yes. I did miss 1 over 1k plus 1 over 0.9k. Sorry, 0.1k, right? Now is it all right?
Sir,
Now I think it is right. Yeah, this is right now. So these are the two equations that we have. We can simply find out the relationship V2 or V1. Sorry, V over I by using these two equations. Fine. Again, here also you can form a matrix of this. Okay. Now that you have the KCL equations, you can now again form the matrix using those equations. Okay. Since we have only two nodes, we have only two matrix, two cross two matrix here. And in this case also, again, you can form the matrix just by looking at it here. Okay, you can simply form the matrix just by looking at it, just as we did in the this example. Okay, so you people try that. This is easy. So form a matrix using using these equations. Okay, and then try to form the matrix just by looking at the network and try to see whether both are the same or not. Okay, coming at the third question. Yeah, let's solve this. Okay, so here I will not solve. I will not write KCL equation. I want you to tell me what will the matrix of this. I want you to form the matrix of this. So tell me how many entries will the matrix have? How many no? How many entries this matrix will have? What is the dimension of this matrix? The matrix that I am going to form for this.
2 cross 2. Two nodes are there.
Yes, yes. So this will be a 2 cross 2 matrix, right? So this will be V1. This will be V2. I don't know what will be here. Okay, all right. Tell me what will be the equation for this node. So okay, tell me what is this? What is this?
Current control current source.
No, it's a current controlled voltage source.
Okay.
Okay, it's a current controlled voltage source. It's a CCVS. All right. So the voltage V1 minus, sorry, rather V2 minus V3 is equal to 6 times Ix, 6 times of Ix. And what is Ix? Ix is current flowing in this direction, in this 10 ohm resistor. So Ix will be what? 6 times minus V1 over 10, right?
Hmm.
Correct? All right. So we have V2 minus V3 is equal to 6 times Ix, which is the same as V2 minus V3 is equal to minus 6 V1 by 10. So from here it will be what? 6 V1 over 10 plus V2 plus minus V3 is equal to 0. How did I come with V3? Oh, please correct me when I make a mistake, otherwise I'll look like a fool. Okay, so this is V2 minus V1, right? There was no V3. Alright, so this is V2 minus V1. Yeah, so this will then in that case it will become 4V1 by 4V1 by 10 minus V2 is equal to 0. Correct? Yeah. Okay, now tell me what will be the, so what do I do when I see a current control voltage source? What should I do to write the matrix? It's a voltage control current control voltage source, right? So what do we do for any voltage source? What do we do? How do we solve the circuits? How do we write the KCL equations when I see any kind of voltage source in my circuit? I form a super node, right? So I'll have to form a super node for these two, taking these two nodes, V1 and V2. I have to form a super node. So so this is my super node, right? What is meant by super node? You simply write the KCL equations corresponding to both the nodes at the same in the same basically in the same equation. You collapse the equations. You'll see you get one equation for this node. You get one equation for this node. But what you do, you simply add them together. You collapse them in a single equation, and that is the equation that you need to write. And the whole that whole equation will become a single equation for a super node, which is consisting of nodes V1 and V2, right? Fine. So this in this case, what will be the super? Now tell me what will be the equation here? The very first equation here. So this is one. This is two. This is one. This is two. So what will be the very first equation here? Yeah. Come on. 1/10, right? First entry 1/10. Yes. Yeah, Ramya. You have doubt. You raised your hand. Okay. Fine. So this is what? Yeah. This is the very first entry is 1/10, right? Here corresponding to this 10 ohms. What about this 5 ohms? Where will it be? Again here, right? 1/5. And then this 2 also, 1/2. 1/5 plus 1/2. Correct? Anything else do I need to write here? Anything else? Yeah, so what will it be equal to at the right hand side? This is the RHS, so this contains the unknowns, known independent sources. So current leaving this node, right, should be equal to the independent current sources coming to this node, right? So this is basically equal to 7 amperes, but 7 ampere is leaving this node, right? So that is why I have to put a minus
minus
sign here,
7.
correct? Yes, fine. So this completes the nodal equation for super node, right? So what do I write here now? How do I fill the entries in the second row here? I use the definition of the current control voltage source, right? That is how I fill the second this thing. second row here, right? I use the definition of the current control voltage source. So the second row, okay, the second row, it corresponds to what? Second row contains the definition of the voltage source, right? So what is the definition of this voltage source? We have this, right? So simply fill this entry here. So it's 4 by 10 times V1, right? Minus 1 over V2, minus 1 into V2 is equal to 0, right? So this concludes the matrix formulation. So this is basically the matrix formulation of this. The nodal analysis matrix for this particular network is this one, is the one that is shown in the right. Okay, so this is the nodal analysis matrix. Fine. So you have any doubt in this? Anyone?
No, sir, it's clear.
Yeah. Let's move ahead. Okay. Yeah. So this is again the same old, same old. So it is again not a problem. You can solve it again easily. So you solve it. So this is not the, oh, same question 2 times. That's not good. Let's remove it now itself. Yeah. So this is an interesting question. Okay. Again, tell me how will you form the matrix for this? So how many entries in the matrix will you have? What will be the
3
dimension of the
cross
matrix?
3
Yeah,
cross 3.
3 cross 3. Nodal. Right. Tell me. This should be very quick, right? This is easy. It has no control sources. This should be very easy. Tell me first this one. This should be V1. This should be V2. This should be V3. Okay. And in this, what should I have? This should be. Tell me what is the first entry here? This is independent sources.
1 by 4 plus 1 by
No, no, no,
3 plus.
no, no. That is okay. This is. I'm not asking about this entry here.
Okay.
I'm asking this.
First one is 6 minus 4.
Yes. 6 minus 4. Yes. So that is okay. Let's write 6 minus 4. Yes.
And
Second is 0, right?
0.
Third is
Third is 4,
Score.
4,
only
4,
4,
sir.
right?
4.
Only
Incoming.
4.
Incoming is 4.
Yes. That's all, right? Now
Right.
tell me the entries here. So this is this is 2. This is 3. 1, 2, and 3. Tell me what will be this
1 by
entry?
4. 1 by
1
4
by
plus 1 by
1
1
by
by
4
4
plus
plus
1 by
1
3
by 3, 1 by 6.
plus 1 over 6. Yes. What will be second one?
Minus 1 by 3.
Minus 1 by 3. Yes. Right. What will be the third one?
Minus 1 by 6.
Yes. What will be the this entry?
Minus 1 by 3. Then 1 by 6 plus 1 by 3 plus 1 by 5.
And the third one will be,
Third one between 2 and 3 gamma minus 1 by 5.
yes, correct. Similarly, what will be this one?
Third one
Minus 1 over
minus 1 by
6,
6.
right?
mm,
Minus 1 by 5.
5. Then you add 1 by 5 plus 1 by
Then 1
6.
by 5 plus 1 by 6,
6. That's it.
right?
Yes, sir.
Yeah. So since this matrix is only containing you see, it contains only this whole network. It contains only what? only
Independent sources.
independent
Sources.
sources and what and resistors. So that is why in this case, what do we see? This whole this matrix here is symmetric, right? You see, it is symmetric about the diagonal. See, minus 1 by 3, minus 1 by 3, 1 by 6, 1 by 6, and this here 1 by 5, 1 by 5, right? It is a symmetric matrix, and again it contains all the elements are like conductance matrix, right? In this case, it is a conductance matrix. It is a G matrix or conductance matrix. Correct? Fine. So you can solve this again. This is very easy to solve. I mean, this is a third order matrix. So you'll have to use Kramer's rule to find V1, V2, and V3. I guess you'll be able to do that. Yeah, yeah, this one. Tell me, how do I solve this? Again, help me write the KCL equations here. So how many nodes are there here? V1, V2, V3. Correct? So the order of the matrix will be how much? It's a 3 cross 3 matrix, right? This is 1, 2, 3. This is 2, 3, V1, V2, V3. What will entry here? Minus 4, right? This will be 0. I will not worry about this one. Tell me again, what should I do here? Again, I have to take a super node for these two, right? Because I have a voltage source here. So I have to take a super node for containing node V1 and V2, right? And then I have to write the KCL equation. So tell me, what will the KCL equation in this first row?
1 by 50
1 by 50 plus,
plus 1 by 150.
this should be in the second one, right?
Yeah.
And
Plus uh, 3 बचा गया.
plus 1 over 55,
5.
right?
Yes sir, yes sir.
Yes, correct. And anything else?
No, there is no common between 1 and 3.
Yes. So what is this?
0,
This term?
0.
No, it should not be.
Oh, sorry.
Why will it not be 0? You see, I'm at the first row here is not just corresponding to node V1. Okay,
Okay.
since we have collapsed node V1 and V2
Hmm.
into a super node. Now the
Yeah.
first row, it basically is corresponding to the super node containing V1 and V2 both, right?
Hmm.
So in the
Okay.
third, we will indeed have an entry here. Okay, and what will
Okay.
that be? Equal to
1
minus 1
by
over
no,
55,
minus 1. Oh,
right?
okay. Okay.
Yes, fine. What about the second? So in the second, what will I do? In the second one, I'll simply write the definition of this voltage source,
V1
right?
voltage source. V1 minus V2
Is equal to 50, right?
50 volt.
So V1
Okay.
minus V2 equal to 50,
50 volt.
right?
Okay.
And the third row, what will I do? I'll write KCL corresponding to third node, right? So it will
Okay.
be what? Between 1 and 3, I do not have a connection. Okay.
Okay.
Between 2 and 3, I have a connection,
Mm, minus
right?
55 plus and then 3. 1
Then
by
right?
Correct, sir. Correct. Sir.
Is equal to 0, correct? So let me write it clearly, otherwise creates confusion. This is the nodal equation, right?
Yeah.
So I guess by now all of you are comfortable with forming matrices, right?
Yes.
Good. So you can solve this again. This is very easy to solve. This is a 3 cross 3 matrix. You simply have to use Kramer's rule. Okay, so just to do a quick recap, tell me what will be the Kramer by using Kramer's rule. What will be V1 here? Yeah, tell me. What will be V1 here? It was what? It will be the determinant of this matrix, right? Let's call this matrix A. Let's call this matrix as, sorry, this is A matrix. Okay, let's use a different color here. Let's call this matrix A. Okay, so tell me, this is a determinant of matrix A, right? And here what will I have? Determinant of what? The first, since I want to find out
First,
V1, so the first column I'll have to replace with what? The,
minus 450, 0.
yes, minus 4, 50 and 0, and this will be 1 over 50 plus 155. This will be minus 1 by 55. This will be minus 1. This will be 0. This will be minus 1 over 55, and this will be 1 over 55 plus 1 over 20. Right? Right?
Mm,
Right. Yes. So this is one, right? Fine. Again, if I want to find out V2, I'll simply replace the second column, right? Simply replace the second column with this. Okay, so
yes.
let's move forward. Yeah, this is interesting. Uh, Tell me how many nodes will I have in this? Okay, so which one should I consider as a reference node here? Which node should I consider a reference node here? I'll take this node as a reference node. I'll take maybe this node, right? Okay,
Sir, the node above 8 volts.
okay. Let's take this one as a reference node. All right. Now tell me how many nodes do I have in the circuit? Let's start by writing. Okay, so let's call this as V1. So this is also V1. What is this? Let's call this as V2. Okay. What else? Again, this is also the same as V2 only. This is also V2. This is also V2. This is also V2. This is also V2. Correct. So let's call this as V3. Okay, and let's call this as V4. Right? Is that all right?
Yes, sir.
Yes. Fine. Now What will be the size of the matrix that I will have here?
4 by 4.
Yes, it will be 4 by 4. 4 cross 4 matrix. Okay, let's solve. Let's try to and put the entries of this 4 cross 4 matrix. It will be big, right? Yeah. So this is 1, 2, 3, 4, 1, 2, 3. At this V1, tell me what will be the entry. First entry, it will be 1 by 1 plus 1 by 5, right? What else? Do you see a voltage source here,
Yes, sir.
which is between 1 and 2? So what should I do here? I should form a super node of 1 and 2, right?
Okay, sir.
Isn't it?
Yes, sir. Yes, sir.
Yes. So tell me what else will I have here? What else? 1 over 5. What else?
Plus 1 by 1. Can you add, sir?
Plus 1 by 1. That I have written already.
Sir, if
So
you
in
are
this,
forming a
now I'll have in the
second.
second, for the second node also here, right? In the
Okay,
first
sir.
one only, because in the for the first row, sorry, for the first row, now my first row will correspond to the KCL equations for both node V1 and V2, because both are collapsed into a single super node, right? Fine. So at node V2, what do I have? 1 over 1 ohm, right? Correct. All right.
Yes, sir.
So this is for anything else at node V2. Anything
So
else do I
the
have?
other resistance of 1
Yes,
ohm,
this is 1
which
over
is
1
between V.
again. This is 1 over 1 again, right?
Yes, sir.
Plus 1 over 1. Anything else? This is also 1 over 1. This is again at node V2 itself, right? Plus 1 over
Yes, sir.
1. And what else? This 1 ampere current source is again connected between V4 and 1 ampere, right? V4 and V2. So this is an independent current source. So we will take it out in this in this part of the uh, matrix equation. Fine. So for this is for node V2 at this level. Now what is the entry at for this 1 comma 3? Tell me. So between V1 and V3, do we have any connection between V1 and V3? We do not have, right?
Okay, sir.
But between V2 and V3 we have, right? We see between
Yes.
V2, this V2
Yes.
node, and V3 we have a connection which is of 1 ohms, right?
1 ohm.
We have to write minus 1. So let's not confuse. Minus 1, right? We have nothing else again in between V1 and V3. V2 and V3. Again between V2 and V4, do we have a connection?
V3 and V4.
V2 and V4, do we have a connection? We do not have anything directly. I mean,
No.
there is a current source, but again, that's not to worry about. All right,
Okay,
let's
sir.
put a 0 here. Now, what will be the independent current source leaving this node? I mean, entering this node V2 is actually equal to 1 amperes, right?
In the,
Am I right? This is actually equal to 1 ampere. This is 1 ampere current source which is entering this super node containing V1 and V2, right?
okay, sir.
So we'll have 1 ampere written here. So are you following this or you have a doubt? I mean, you are not able to follow this.
Sir, the 1 ampere current can be divided through the other path of 1 ohm. Sir, at V2, sir, the independent current source is supplying, sir, 1 ampere.
Yeah, this independent current source 1 ampere
The
is flowing
whole
in which node?
1 amp, sir, there are 1 ohm, 3 1 ohm paths are there. Sir, how can we say that the whole 1 ampere current will flow through the supernode, sir?
One second. Okay, tell me what is this node? What is this node? What is this node? What is this node? And what is this node and this node? Aren't they all the same?
All are V2.
No,
All are
sir.
V2, right? They are all
All
the
are V2.
same. Correct?
Mhm.
So okay. This might be a little confusing. So let's uh, reduce this slightly. Okay. So this will ease a lot of confusion. So uh, this is the circuit we have. We have a reference in between, in the middle, right in the middle, and we have this 1 ohm. Then we have a 10 volt current voltage source. Again, we have a voltage source here. Okay. 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 What else? How do I write it? Let's do something else. Let's take node V2 here. From node V2 we have 1 ampere, 1 ohm here. We have nothing else. Okay, we have a 1 ohms, right? Oh, sorry. So this is V2. This is your ground, and what is V3? Yeah, this is V3, and this is V4. Is this clear now? I mean, this is the same circuit that I drew here. This is the same circuit actually. Okay, so here you see clearly this 1 ampere, this 1 ampere current source is flowing into node V2, right? All right. So, where was I? Yeah, this is the this concludes the first. Sorry, this concludes the first row, right? Now in the second row, what should I do? I formed a super node using 1 and 2. So I should better write the voltage definition, voltage source definition. So what is voltage source? This 8 volt is between what, V1 and V2, right? So V1 minus V2 is 8 volts. So let's write that. So V1 minus V2 is 8 volts, correct? All right. What else? Now let's write the KCL equation for the third one. Again, in the third one, you see we have the same thing as the first, very first question. In the third node here, you see a voltage source connected between reference and the third node. So V3 is actually simply equal to 8 volts, right? So I do not need to write a KCL equation here. I simply need to write the definition of the voltage source here. Okay. So it will again be V3 minus 0, which is nothing else. It is again equal to 8 volts, right? Now coming to the fourth node. Tell me, what will be the KCL for this? I mean, how should I fill the entry here? Yeah, so it will be 1 over
1 by 5.
1 over 5 where? In the 4 comma 4, right? 1 over 5 plus anything else? Nothing, right? 1 over 5 here, and 1 over 5 is this one, 5 over is connected with V1 and V4.
V1 and
So
V2.
this will be minus 1 by 5 here, right?
Okay,
And
sir.
the other two entries will be 0. And what will be the this entry here? It should be the current source, independent current source entering at this node, right? But you see that at node V4, the current is what? It is leaving this
Leaving.
node, right? So it should
Minus
be
1, minus 1.
minus 1 ampere, right? Yeah. So this concludes the matrix formulation of this particular network. So this is the matrix. Is that point clear? I mean, is the matrix formulation, the steps that I followed, clear to you?
Yes, yes, sir, yes, sir, yes, sir.
Yes. So cool. So from here you can find out whatever you want to find. So from this you can find out what will be the voltages. Once you have all the voltages, then you can find out what is the current here, okay, and what is the current here. So from there you can find out what is the current that will be applied, that will be coming out here, the current I here, okay, and this will come out from KCL equations, not a problem. You could also solve this question without forming the matrix easily, because this is a lot of things are connected in parallel here. So it would have been much easier if you didn't form a matrix and simply solve the circuit. You see this register here and this register here, these are in parallel, right? From here you see this resistor, this resistor 1 ohm and this 1 ohm resistor here, these two are in parallel, right?
Yes, sir.
Correct. And if you remember something about source transformation, if you know something about source transformation, do you know what is source transformation?
Conversion of source voltage to current
Yeah,
source
so
to voltage
basically
source.
it's basically nothing but Thevenin and Norton's equivalent, nothing else. So if you have a voltage source, okay, so let me, so if you have a resistor in series with a voltage source here, this is RS and this is VS, okay, so this is equivalent to a network which is This is RS and this is IS, which is equal to VS over RS. Okay, this is the same as that. These both are equivalent. While looking from this side, okay, from this side, right hand side of the green box, that green boundary that I've drawn here. From the right hand side of the green boundary, when you will see, look at this network, both the networks will seem equivalent. Okay, the terminal characteristics, which is basically, I mean, the terminal characteristics looking between these two terminals, okay, for the first case will be the same as the terminal characteristic looking between these two terminals for the second case. So this is the second case, this is first case, and this is second case. All right. So if you know source transformation, you can see that this V3, this not V3, but this 8 volt is in series with 1 ohm, and this can be transformed into a a current source in parallel with 1 ohm resistor, right? So I mean, if you solve this, this will be very easy to solve using source transformation or not. So this will become very easy to solve. Okay, fine. So let's online. Yeah, quickly. So this is the last weightage formulation that I want you to do. After that, you can go home. So yeah, so tell me how many what will be the size of the matrix here? This is a 4 cross 4 matrix, right?
4 cross 4.
Yes. So quickly tell me the entries, and then you and I both can go home and both can relax for this. So 1, 2, 3, 4. Oh, V1, V2, V3, V4, independent current sources. All right. So go on. Tell me the entries. This is V. This is 1. This is 2. This is 3. This is 4. Yes. Okay. Tell me the entries. What will be this entry? 1 comma 1. First of all, what should I do? I should identify all the voltage sources and current sources, right?
Right.
So this is a voltage source here. This is a voltage source here. So what should I do? I should
V1
form a
minus
super node
V2.
V1 and V2, and I should form a super
V1.
node V3 and V4, right?
Okay.
Yeah. So what are the definitions of the voltage source?
V1 minus V2 20 volt.
V1 minus V2
20 volt.
20 volt is the first one.
V3 minus V4 3Vx, and Vx is
What is Vx?
mm,
V1 minus V4 into,
the
oh sorry, V1 minus V4, right?
V1 minus V4. Mm,
Correct?
yes, sir. Yes, sir.
Yes. So this will be what? V3 minus V4 minus 3V1 plus 3V4 equal to 0. This will be what? Minus 3 times V1 plus 4 times, sorry, plus V3, or let's call it 0 times V2 plus V3 minus or plus 3 times V4. Oh no, sorry. Plus 2 times V4 equal to 0. Correct? Is it right? Is it right? Yeah, it looks right to me. This is correct. So we have these two. Sorry, this is the first, and this is the second one. So this is the second one. All right. So tell me, what will be the first entry here? 1/2 plus 1/3, right? Anything else?
Mm,
No, I don't think so, right? So after that,
okay.
what will be the 1, 2 entry?
Mm,
Remember, I have formed a super node, right?
mm.
So
1
tell me.
by
Yeah, tell me. Yes, it will be
1 by
1 over
6 or 12.
6, correct? 1 over
Mm.
6. What else?
And again, V2, V3.
Nothing else, right?
Mm.
Because I have nothing else connected to node 2. We have only two elements, right? Connected to node 2. This is the
Right,
one,
right.
this is other one, right?
Okay,
So
okay,
this 10
okay,
ampere will come in the independent sources thing, right? So this is
okay.
independent sources. So fine. So this is this will be equal to what? 10 amperes, right?
Yeah.
Correct. Okay. What will be between V1, so 1 comma 3, third entry?
1 by 4.
1/4
No, 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 no. No.
minus 1/6, right?
Okay. Mm-hmm.
I am talking about the for the KCL equations for first super node,
Super node.
right?
Okay, 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 sir. Okay, sir.
This is
Understood.
the one, correct? So minus 1/6. Anything else?
Mm, mm, yeah. Between 1 and 4.
Yes, 1 and
There
4.
is
Yeah, I have that. So it will be minus 1/3,
3,
right?
3, 3, 3. Mm.
Correct. Yes. So that concludes the first row. Now, what will be the second row? It contains the
So,
definition of the voltage source, right?
voltages.
So it is V1 minus V2 has to be equal to 20 volts.
20 volts. Okay.
Yes. What will be the third row? Again, again for third row, again I have a super node, right?
No, V3 minus V4.
Yes. So what will I write here for the third row? 1 over
Minus
4.
3,
Sorry.
minus
First, let's write 3 comma 3 entry. So it will be 1 over 3. Sorry, 1 over 4 plus 1 over 6. Nothing else, right?
yes.
Okay. Now let's write 1 comma 3 comma 1. This entry. What do I have connection between? What connections do I have between 1 and 3? No connection, right?
No connection. 0.
Okay, so this is 0. So what connection do I have between 2 and 3?
Minus 1 by 6.
Correct. Now what connection do I have between 3 and 4? I mean,
Mm,
other than the voltage source, anything else?
3 and 4. Minus 1 by 1 over 1.
There is nothing else, right? Between 3 and 4.
Okay, okay, okay,
So it should
okay.
be 0, correct?
Mm, mm.
Huh? Yeah, and I do not have any independent current sources. Oh, sorry, I made a mistake here. I do not have a connection between 3 and 4, but from 4 I have a connection, right? Right?
1 yes. Minus
Okay,
1
so
yes.
here also, correct? So tell me, what will be the equation at this entry? What will be this entry?
Between 4 and 4. 1 minus 1.
It will be 1, right? Here.
One.
Okay. 1 over 1. And what is plus 1 over 3?
Mm,
Correspond to this one, right?
mm,
And this again 1 over 3 is between 1 and 4, right? So here I should have written minus 1 by 3.
mm, mm.
Correct?
Okay.
Yes. And this should be equal to what? Do I have a current source, independent current source at supernode which contains 3 and 4?
No.
No. So it should be 0, right? Fine. In the fourth and the last row, I write the definition for the
Mm.
voltage
Minus
control
3,
current voltage source, which
minus
is
3,
equal to
0,
minus 3 times V1, 0 times V2,
0,
1 times V3,
and 2
and
times V.
2 times V4, which is equal to 0, right?
Okay.
So this is the final matrix. Okay. Yeah. So that's it. I think I discussed everything which I wanted to discuss today. All the sample problems. So I guess you by now you have sufficient confidence, right, in
Yes,
forming
sir.
matrices.
Yes.
You can form matrices now. Fine. So all right. So I think I've covered everything. So this concludes the discussion session for today. Okay. So thank you for joining
Yes, sir.
everyone.
Thank you. Thank you.
Yeah. Thank you for joining everyone. Give 1 second.
Thank you, sir.
Yeah. Yeah. Welcome.